If you've ever worked on a system where something went wrong and you had no idea how it got into that state, this video is for you. Today we are going to talk about two architectural patterns, event sourcing and CQRS. These come up constantly in system design interviews, and they solve a real class of problems that CRUD-based systems simply can't handle well. By the end of this video, you'll understand exactly when this pattern is worth complexity and when it is a complete overkill. We're going to build up ideas using a few simple examples, but first let's start with a problem. Imagine that you are building inventory management for a clothes shop. You have a products table in a SQL database. Each row has a product ID, name, and current stock count. When someone buys a jacket or pair of shoes, you just run an update. You just subtract one from the stock. When a new shipment arrives, you run another update. You add how many items arrived. This is how most applications work, and honestly, for a lot of use cases, it's completely fine. But now your operations manager comes up to you with a question. The blue denim jacket shows 12. 2 weeks ago, it showed 47. What happened to these 35 units? And you have no answer, because every time you ran that update, you replaced the old value. The history is gone. So all you have is where you are now, not how you got there. This is the fundamental limitation of state-based storage. You store the current snapshot and you lose the history. Now imagine a second question. We had a bug in our discount calculation last Tuesday. Can you figure out which orders were affected and what the correct prices should have been? Again, you can't answer this reliably if you have been overriding the state. The evidence is gone. And this is exactly the problem that event sourcing is designed to solve. And the whole idea behind event sourcing is quite simple. Instead of storing the current state of your data, you store a log of events that happen to the object. The current state becomes something that you can derive from that log, not something that you store directly. So in the event sourcing system, the event storage plays the central role. It keeps all the events that happen to our objects. I have sample events here, so let's just copy them to visualize things. So now instead of updating the stock count, we keep individual events, and we can replay those events whenever we want. We can replay them for a specific day in the past even to identify the stock count for that day. When you have a system built with event sourcing, you get 4 capabilities that are simply impossible with a CRUD model. First, complete audit trail. You now have a perfect, evident record of everything that happened. You scroll through the event log and you can see which events caused the stock to change, when and why. This is valuable for compliance, support, and debugging. Temporal queries. You can reconstruct the exact state of your system at any point of time. Want to know what the inventory looked like at midnight on January 7th? Replay all events up to that timestamp. You're essentially time traveling through your data. Third, replay in dev environments. Imagine you have a bug in production that you can't reproduce locally. And with event sourcing, you can take the real sequence of events from your production system and replay them in your dev or test environment. You get the exact conditions that triggered the bug, not a made-up test scenario, the exact thing that happened. You can go through it, pause it, go to a specific position in history. It's like having a time machine for your production system. Fourth, event replay for corrections. Let's say a customer bought 2 jackets 6 months ago and returned one of them, but the return was processed incorrectly and the stock was never updated. In a CRUD system, you'd have to manually patch the database and hope you got it right. In an event source system, you can reverse the incorrect event, insert a correct event in its place, and replay forward from there. The system recalculates all the downstream effects automatically. Event sourcing has disadvantages. Imagine you have a client that needs to get the count of shoes in the system. The client will have to iterate over all the events to calculate a single number. As there can be thousands or millions of events, such simple operation will definitely take an unreasonable amount of time. To solve this problem, we break the system into two parts, one for writing and the other for reading, using CQRS pattern. CQRS stands for Command Query Responsibility Segregation. The name sounds intimidating, but the idea is straightforward. We have two distinct components. The right side handles commands, things that change state. When an item is purchased, when stock arrives, when a return is processed, those commands come in, get validated, and produce events that are appended to our event log. The read side handles queries, things that retrieve state. It has its own data store optimized for fast reads. Whenever a new event is written on the right side, a separate process, a projection consumer, picks it up and updates the read store. Reads go directly to the pre-computed store and get instant results. These two sides are completely independent. You can scale them separately. You can choose different databases for each. The write side might use a simple append-only store optimized for high throughput writes. The read side might use a cache or search index optimized for complex queries. One important thing to understand: CQRS and event sourcing are not the same thing. You can use CQRS without event sourcing. You can use event sourcing without CQRS. Though, as you've seen, event sourcing almost always comes with CQRS because of the read performance problem. They complement each other very naturally, but they are separate ideas. Here's the thing. You've probably already used a massive real-world implementation of event sourcing and CQRS. Open your AWS Billing console. Think about how AWS Billing works. When you spin up an EC2 instance, AWS doesn't immediately update a row in a database with your charges. What they do is record a usage event, a fact that this account ran this instance type in this region for this period of time. These usage events are generated continuously across millions of customer workloads streaming in from every AWS service. Those usage events are the event store. You never see them directly, but they are the source of truth for everything billing related. What you actually see in the console, there's the dashboard showing your month-to-month estimate. There's Cost Explorer where you can slice usage by service, region, and tag. There's the monthly invoice, a point-in-time snapshot of all charges for that billing period. There's the cost and usage report for advanced analysis. These are different projections of the same underlying event stream. Same events, different read models optimized for different query shapes. That's textbook CQRS. And there's the eventual consistency moment you've definitely felt personally. You spin up an EC2 instance, you check the billing dashboard 5 minutes later, and the change isn't there yet. That's not a bug, that's the projection consumer catching up to the event stream. The events have been written, the read model just hasn't been updated yet. So to summarize, event sourcing is about storing what happened rather than just what is. It gives you audit trails, time travel, production replay, and the ability to correct past mistakes. Its cost is read performance, which CQRS solves by separating writes from reads and pre-computing state. AWS Billing is a real production example of both patterns working together at massive scale. In the next video, we are going to take everything we've covered here and build it on AWS, using DynamoDB as the event store, Event Bridge to fan out events, Lambda consumers to build projections, and CDK to write it all together. If this was helpful, subscribe. The AWS implementation video is coming next. See you there. Bye.